As you might be aware, we went through a little bit out of order in our textbook when we were doing our last two units. We had Chapter 4 on matrices before we talked about systems in Chapter 3. The reason I did that is because you can use matrices to solve systems of equations. And while initially it may seem like, why do I need another method? We've learned 3 different ways already to do these problems. This often is the most convenient way, especially when you get into bigger problems. So to kind of set the stage here, in this video, we're going to talk strictly about how you can take a system, like one of the ones you see here, and write it as a matrix equation. So we're going to be using matrices to represent the same problems you see there written in black. So the first thing I'm going to do on this, in terms of rewriting it here, I'm going to make a matrix with the coefficients on my x's and y's. So if this is my problem, I have 3x and it's minus 5y. I'm going to put a 3 and a negative 5 in my top row. On the bottom row, I have negative 13x plus 2y. I'm going to put a negative 13 and a positive 2. So you make a matrix with the coefficients, the numbers in front of your x's and y's, making sure that they're in order over here in the original problem. And what I'm going to do after that is put a times sign here, and I'm going to put a little matrix, a 2 by 1, with my variables. I'll have my x and my y right here like that. Now, if you recall, when you have a matrix multiplication problem, you use karate chop action. If you think about what will happen here, when you take this guy and multiply it against this one, the x is going to land on the 3, make it 3x. The y is going to land on the negative 5, make a minus 5y. And you combine the pieces so you get 3x minus 5y, exactly what you had right here. When you karate chop the bottom, you get negative 13x plus 2y. It's the same thing that you get over here in the black, just written as a matrix. If you do your karate chop, you get back to there. And this is going to be equal to the answers, the numbers on the other side. So I have equals 10, negative 9 like that. And that's it. Again, for right now, it's going to seem like, why would you want to do that? Why is that helpful in the slightest? In the next video, you're going to see why. In this video, we're just practicing rewriting our problem. The red and the black both demonstrate the same thing. So on my second row right here, it's the same sort of deal. But on the first problem, I had my x's and y's nicely lined up. That's not the case on number 2. So for this one, I'm going to reorganize it so it's ready to go. I'm going to subtract 5x on both sides here. I'll get negative 5x plus y equals negative 4. And this one, the x and y are just flip-flopped. I'm just going to rewrite them in the other order. It'll be negative x plus 2y. Just flip them over. So this will be negative x plus 2y equals 50. And now I'm good to go with turning it into a matrix equation. First matrix is my coefficients, negative 5 and 1. Then I have negative 1 and 2 right here. I have my variables, x and y. And if you do your karate chop, you get back to here, equals my answers on the right side. So, final problem in the video is a 3 by 3. It's going to require a 3 by 3 matrix because we have x's, y's, and z's in this one. 3 variable systems can happen. All of ours have just had x's and y's. There's nothing that says you can't toss an extra variable or 2 in there. But they're not problems we're going to focus too much on doing by hand. We're actually going to use matrices to solve them. So it's going to be a good method that you guys will appreciate because it's really kind of a pain to solve these things by hand. It's pretty doable, though, with matrices. So anyway, the process is exactly the same. I guess I'll just go ahead and start my matrix here. In this one, though, I have x's, y's, and z's. I'm going to have a 3 by 3 matrix in this guy right here. Because I know my second matrix is going to be x. That's where the variables go. I'm going to have x, y, and z. Well, if I have 3 here, to do the karate chop, I'll need 3 there. So, coefficient on the x, just doing it like normal. We have 2, and we have negative 6, and then we have 4. On the second row, I have a negative 4 for x. There is no y, though. I put a little blank space there to kind of make that clear to see, but it doesn't have to be written like that. There's no y in this one. You can think about that as a plus 0y, because it's not even there. So if a variable is missing, you put a 0 in for it. And then we have a plus 5. Bottom row is out of order, so I need to subtract my x from both sides. Have to add 7 on both sides. Just reorganize it. You get negative x plus 2y plus 3z equals 7. So I get -1, 2, 3, and then I just put my answer matrix. So I'm looking at 17, -40, and finally 7.